We're handling arithmetic to you people. Hope all are fine. So we'll start with the first chapter, rational numbers. So this is not actually you have learnt about numbers. We'll just brush up what we have learnt about numbers. So you can see the picture here. You have natural numbers, whole numbers, integers and rational numbers. So you people are familiar about natural numbers, whole numbers and integers. So what do you mean by natural numbers? Counting numbers or numbers you count with, like 1, 2, 3. So it starts from 1. So 1, 2, 3 up to infinity are called as what? Rational numbers. Then what do you mean by whole numbers? All counting numbers along with 0 are called as whole numbers. Then what do you mean by integers? All whole numbers and natural numbers and their opposites are called as integers. So we'll have negative numbers, positive numbers along with 0 are called integers. So we know about natural number, whole number and integer. Now, set of these integers, whole numbers and natural numbers are called as rational numbers. Rational numbers are nothing but fractions. So you people are familiar with fractions. So symbolically we can say rational numbers are the numbers with the form p by q where q is not equal to 0. So here the numbers will be in fractions. It can be in whole numbers as well as integers. You can find positive numbers as well as negative numbers. It can be in fractions. It can be in whole numbers. But it should be in the form of p by q, where q is not equal to 0. So now we shall discuss with properties of rational numbers. So you people are familiar about properties like closure property, commutative property, associative property, distributive property and identity elements of addition and multiplication. So you have studied with natural numbers, whole numbers and integers. So today we are going to discuss with these properties with respect to rational numbers. So closure properties. So rational numbers are closed under addition. Yes or no? Yes. So you can, in general, we can write it as a plus b is equal to c. So c will be a rational number. Example, 8 plus 3 is equal to 11. So 8 is also a rational number. 3 is also a rational number. When you add this, you will get 11, which is a rational number. And it is also closed under subtraction. So a minus b is equal to c, which is also a rational number. So for example, 25 minus 11 is equal to 14. So 14 is also a rational number. And it is also closed under multiplication. That is, for any two rational numbers a and b, a into b is equal to c, which is a rational number. So example, 4 into 2 is equal to 8, which is also a rational number. But it is not closed under division because a by 0 is not defined. So a by 0 is nothing but infinity, which is not defined. That is why division is not closed under, rational numbers are not closed under division, under closure property. Next, commutative property. So rational numbers can be added in any order. Therefore, addition is commutative for rational number. For example, a plus b is equal to b plus a. We can reverse and add it. So when you reverse and add it, we'll get the same sum. So for example, we'll take A as minus 3 by 8 and B as 1 by 7. Then A plus B will be minus 3 by 8 plus 1 by 7. It is LHS. RHS is B plus A, that means 1 by 7 plus minus 3 by 8. By taking LCM, we can, 56 is the LCM, and you can get minus 21 plus 8, it is equal to minus 13. In this part, 8 plus minus 21 is equal to minus 13. So LHS is equal to RHS. But it is not commutative for, subtraction is not commutative for rational numbers. So if you take example 2 by 3 and 5 by 4. So when you subtract this, 2 by 3 minus 5 by 4 will get 7 by 12 you will get in LHS. In RHS, 5 by 4 minus 2 by 3, LCM is 12, and 15 minus 8 is equal to 7. So minus 7 is not equal to plus 7. Therefore, LHS is unequal to RHS. It proves that subtraction is not commutative for rational numbers. In the same way, it is closed under multiplication. So we'll take A as minus 7 by 3, B as 6 by 5. When you multiply, 7 6 are 42, minus 42, 3 5 are 15. In the same way, if you interchange the numbers here, 6 by 5 into 7 by 3, we'll get minus 42 by 15. So which is equal to each other. Therefore, we can say that multiplication is closed under commutative property. So if you take division, it is not closed because minus 5 by 4 divided by 3 by 7, take the reciprocal. Minus 5 by 4 into 7 by 3, it will be minus 35 by 12. But in RHS, 3 by 5 divided by minus 5 by 4. When you take the reciprocal, 3 by 5 into 4 by minus 5, we'll get 4 3s are 12, 7 5s are 35. That is minus 12 by 35. So LHS we get minus 35 by 12, but in RHS we get minus 12 by 35. Both are here unequal. Therefore, division is not closed under commutative property. Next, associative. So associative property, everybody knows. You have to take three numbers, A, B and C. So A plus B plus C is equal to B plus A plus C. So brackets are most important here. So you people know whatever it is there in the bracket, we have to solve it first. Then we have to add it to the other number. So we'll take three numbers like 3 minus 3 by 2 by 3, 3 by 5 and minus 5 by 6. So when you, in the next step we'll add which is in the bracket, that is 3 by 5 and minus 5 by 6. By taking LCM, 6 5 is 13. So if you, after calculation you'll get minus 7 by 30 plus minus 2 by 3. So when you add it, you will get minus 27 by 30. If you want, you can simplify or you can keep it as it is. But in RHS, now bracket will be for minus 2 by 3 plus 3 by 5 plus minus 5 by 6. So 2 by 3 plus 5 by 3 by 5, which is equal to minus 1 by 15 plus minus 5 by 6, which is also equal to minus 27 by 30. So we can say that associative property for addition is closed. So subtraction is not associative for rational numbers. Okay, but here multiplication is associative for rational numbers. So we can take any three numbers that we have taken. Minus 2 by 3 into 5 by 4 into 2 by 7. So bracket is for 5 by 4 and 2 by 7. Multiply that first. 5 into 2 is 10. 4 7s are 28. That into minus 2 by 3. So what do you get? 10 by 42. The same way bracket we have to put it for minus 2 by 3 into 5 by 4 into 2 by 7. So minus 10 by 12 into 2 by 7. What do you get? Minus 10 by 42. So we can say that LHS is equal to RHS. So multiplication is associative for rational numbers, we can conclude. The same way, division is not associative for rational numbers. You can give your own values and you can check it, so you will get unequal. Next is distributive property of multiplication over addition and subtraction. So for all rational numbers A, B and C, A into B plus C is equal to AB plus AC. The same way, under subtraction, A into B minus C is equal to AB minus AC. So we can take the example. Right hand side is A into B plus C. So 4 into 2 plus 6. What you get? 2 plus 6 is 8. So 4, 8 4s are 32. In RHS, AB plus AC. AB is 4 into 2. AC is 4 into 6. So 8 plus 24, it is not equal. It is plus 24, which is equal to 32. So here LHS is equal to RHS. So it will be valid for next part, that is A into B minus C is equal to AB minus AC also. Next, multiplicative identity property. For any number A into 1 is equal to 1 into A, which is equal to A. So product of any number and 1 is equal to that number itself. So 1 is called multiplicative identity. For example, if A is equal to 6, then 6 into 1 is equal to 1 into 6, which is also equal to 6. Identity property for addition. So if, when you add 0 to any number, the sum is the same number. So A plus 0 is equal to 0 plus A, which is equal to A. So 3 plus 0 is equal to 3. Any number. 45 plus 0 is equal to 45. So that is the identity element for addition. So identity element for multiplication is 1. Identity element for addition is 0. Next we have a table here where you can remember the properties easily. Closure property. So A plus B belongs to Q. A minus B belongs to Q. A into B belongs to Q. A divided by B belongs to Q. That is general form. So A plus, next commutative property, A plus B is equal to B plus A. And as addition, it is valid. And as subtraction, it is not valid. So A minus B is not equal to B minus A. The same way, A into B is equal to B into A. It is valid. But A divided by B is not equal to B divided by A. So operations you can remember like this easily. The same way, associative property, A plus B plus C is equal to A plus B plus C. But under subtraction, it is not closed. But under multiplication, it is closed. But under division, it is not closed. Distributive property, it is valid only for addition and subtraction. For multiplication and it is division, it is not applicable. So homework is given. You have to check the property for these values. Distributive property and commutative property you have to check. You know the general form and do the homework and write these properties in your classwork along with the example. Okay, thank you.